So an apple farm yields an average of 41 bushels of apples per tree when 25 trees are planted on an acre of ground. And each time one more tree is planted per acre, the yield decreases by 1 bushel per tree as a result of the crowding. So how many trees should be planted in order to get the highest yield? Or in other words, we want to maximize the number of bushels. That's what the highest yield means. So we want to maximize the number of bushels. I'm going to call that B. Okay, we need to define a variable, though, in order to work this problem. So the way to define your variable to make this, I guess, the easiest is to focus on this sentence right here. It says, each time one more tree is planted per acre, the yield decreases by 1 bushel. The idea is it's implied that we're probably going to plant more trees, even though it decreases the number of bushels per tree. So let's let X be the additional number of trees planted per acre. This is beyond the 25 trees. So we're starting out with 25, and then X is however many trees beyond 25 we decide to plant. Okay, so let's try to write an equation for B. I think it's going to be kind of hard to jump straight to the equation, so let's write it out in words first. So the number of bushels in words, let's see, is the total number of bushels we get. Okay, it's the number of bushels per tree times the number of trees. So number of bushels per tree, all right, times the number of trees. And actually, I'm not being very specific here. This is really the number of, capital B is the number of bushels per acre. Okay, we don't know how many acres we have. We're just focusing on maximizing the number of bushels on 1 acre. So this is really number of trees on 1 acre. On 1 acre times the number of bushels per tree. That will give us number of bushels B per acre, total number. That's what we want to maximize. Okay, so the number of bushels per tree, let's see. Right now we have 41 bushels of apples per tree. Okay, so it's 41 plus or minus something. But for each additional tree that's planted, the yield decreases by 1 bushel. So if we plant X additional trees, then we lose X bushels per tree. Okay, so that's number of bushels per tree right there. Then the number of trees per acre, well, we're starting with 25 trees per acre, and we're going to plant an additional X trees on top of that. Now, if we do this whole problem when we get that X is negative, then that would mean we should take away trees and plant fewer than 25. Okay, so let's simplify and FOIL this first. Let's see, 41 times 25. I'm going to open my calculator for that. So FOIL that out, and then try to find where it has a maximum. So 41 times 25 is 1025. Okay, so 1025 plus 41x minus 25x. 41 minus 25 is 16x minus x squared. Okay, that's the thing we want to maximize. So that's our objective function. So we're going to take b prime, 16 minus 2x. So that's going to equal 0, where x is 8 is our critical value. We can check real quick that it's a max and not a min by doing the second derivative. The second derivative of b is negative 2, which is less than 0, so b is concave down. So if something's concave down, we do have a maximum at the critical value. Okay, so X is 8. The question is how many trees should be planted on an acre? So we're starting out with 25 trees, and we're going to plant an additional 8 trees beyond that, so 33 trees per acre.